In some rural areas of Africa and Asia, women have to walk for hours to reach their nearest freshwater source. Even after this long journey, that can sometimes be as long as 6 kilometers, the water is often dirty and contaminated. Then they have to lug their water all the way back to their homes. This process has to be done almost every day. It takes so much time, sometimes hours, to get the water. Not to mention, if the water is contaminated, people can get very sick or even die. As a group, we wanted to design a device that would reduce the amount of time needed to get the water while simultaneously cleaning the water and killing bacteria. We started brainstorming some ideas. Most of these original ideas consisted of some sort of cart that would generate electricity as it moves to power a filter that would then clean the water. We prototyped a design for a wheel that could possibly be used to generate electricity. We 3D printed a shell of the wheel so that it was hollow inside. We then put a wire coil inside of the shell and put small magnets inside of the wire coil. As the wheel spins, the magnets move inside of the wire coil and generate electricity. We tested it using a galvanometer, and we did actually get a small amount of current flowing through the wire. We realized, though, that this was not going to generate enough current to power a filter, even with all 4 wheels generating electricity. We decided to take a different approach to our project. We thought, what if instead of making it easier for people to come to the water, we made the water come to the people? We had a few ideas. We remembered from our research that we had seen that many rural villages have wells. Unfortunately, though, a lot of these wells are unusable due to sewage contamination. By making these wells usable, we could really reduce the amount of time it takes for people to get their daily water supply. It would be right at their doorstep. That is where we got our idea for the PVC purifying pump. This pump is simply made out of PVC pipe. It includes a piston, which moves up and down inside of another pipe to cause water to flow through a series of valves. These valves allow water to flow through one end, but not back out, so the water continues to flow through the pipe, creating a pump. We then attach a Brita filter, which contains activated carbon to filter out dirt to clean the water. When used, the pump could move water out of a well and make it drinkable at one time. It is easy to use and can be taken apart for easy transportation and storage. It also costs a lot less than the initial design, which would make it more widely available to people in need of it. Reducing the amount of time lost in the day collecting water could be hugely beneficial to women in developing countries. It would open up time for work and education, which would be a huge step towards positive change.